First thing I want you know, yeah. Something called exponent laws. Last term. If I asked you to multiply these two together and write the answer as a single power, okay, don't evaluate it, like don't punch it in your calculator and find the answer. I just want the answer as a single power. Do you remember what to do? Yep. 7 base stays the same, and we add the exponents. So it's 7 to the 13th. Okay? If I said this, what would your answer be? I don't want you to evaluate it. I just want you to write it as a single power. Romy? To the 12th. -5 in brackets. 12?
15. On my phone.
15. We're multiplying, so we add. We still add. Okay? That's all right. That's all right. It's allowed. It's first day.
Yeah. Yeah. But like you talked should we make it? Where did it now?
What if I said that?
Yeah.
Well, when we multiply powers, we add the exponents. So we subtract the exponents. So what would your answer be?
11. 4.
Okay. So those were two what we called exponent laws. The multiplication exponent law and the division exponent law. There's one more we're going to do. What happens when we raise one power to another power? That's actually what you do. Yeah. But to show you why that works, remember, 8 to the 4th is 8 times 8 times 8 times 8, right? We are asked to take this and multiply it by itself 3 times. So I'm asked to take these 4 8s being multiplied together, times it by another 4 8s being multiplied together, times it by another 4 8s being multiplied together. So I'm doing this. Well, how many 8s am I multiplying together? 4, 8, 12. Well, I don't want to have to write this out all the time. I want to be able to be given this and go directly to the answer. So what's the relationship? We multiply the exponents. So that's the third main exponent law that we're going to look at. When we have some number x raised to some number m, these could represent any numbers, and we raise that to another exponent, base stays the same always, and we multiply the exponents. Yep. Oh yeah. What's that?
Like we'll get to have ours.
Yeah. Yeah. Okay. So Remember, when you see questions like this, you could be asked two things. You could be asked to write it as a single power where you use the exponent law, or you could be asked to evaluate it. That's when you pull out a calculator and punch it in. These ones, we're not asked to evaluate them. I'm just asked to write this as a single power. So I've got -7 in brackets, parentheses, to the third, and I'm raising that to the second. How can I write that as a single power? What's the base? Not 7, -7. Need the parentheses. And what do I do with the exponents? Multiply them. That's it. I'm actually going to skip ahead to C and then we'll do B. What would this one be? 6 to the power of 14. Base stays the same, multiply the exponents. This one, notice the negative is not inside. Okay, so that if the negative is not inside, that means we put it on at the end. So that means we've got to do this and then put the negative on at the end. Bless you. So I'm going to put negative, and what is this as a single power? 2 to the power of 20. And that's it. I stop there. No parentheses around the -2 because there were no parentheses around the original -2. So I'm done. So now we know the 3 exponent laws. When you multiply powers, add the exponents. When you divide powers, subtract the exponents. When you raise one power to another, multiply the exponents. So keeping those in mind, notice the instructions on this last example, or these last 2 examples. You're asked to simplify them, so you want to use exponent laws as much as you can, and then evaluate at the end. So we don't want to start going, oh, this is 9, this is 27, and then start doing that. That's not what we're asked to do. Is there an easier way to write 3 squared times 3 to the third? What is 3 squared times 3 to the third as a single power? 3 to the 5th, because I add exponents, right? So it's 3 to the 5th. And I still have parentheses and I'm erasing it to the third. Minus, well, I can combine those into a single power. What's that? 4 to the 5th. And I'm still raising that to the second. So I did the multiplication exponent law. There's another exponent law I can do. What's this? 3 to the 15. Minus 4 to the 10. There are no more exponent laws left to do. I can't combine these two because they don't have the same base. So this is where I pull out my calculator and actually find this, and subtract it. So 3 to the 15th. 3 to the 15th should give you 14,348,907. 14,348,907.
You overtime.
4 to the 10th should give you 1,048,576.
Oh,
We're just using our calculator. Remember, you should know how to do powers on your calculator. And now we just subtract these two answers to get a final answer of 13,300,331. Okay? So this was the simplifying part, where we didn't really need a calculator to do this. Okay? We used our knowledge of exponent laws to get this all the way down to this. This part is actually where we started calculating or evaluating. For B, not yet. You should be able to get the answer in less than 5 seconds. Look at the question. Look at the entire question. You actually don't need to use a calculator at all. You don't need to simplify anything at all. 1. Why? It doesn't matter what we do in here. We don't need to add these because whatever answer this is, when I raise it to the 0, I get 1, not 0. 1. Anything to the 0 power is 1. Where's the 0? Did you just ask for the 0 once? Did you find the 0? No, it's on the paper. Find the 0? Oh my God. Where's the 0?
I didn't see that.
Yeah, are these the glasses?
No.
Oh.
What is that?
Oh, yeah. Okay.